Lesson number 1. What is the difference between machine learning and deep learning? Hello, I'm Dr. Barak Orr, and welcome to the first lesson in the course Foundations of Modern Deep Learning. Before we understand what a neural network looks like or what gradient descent is, it's important to pause for a moment and build a foundation. What exactly is machine learning? What is the difference between it and deep learning? And why is this distinction critical for engineers, researchers, and developers? Machine learning is a field in which we build systems that are capable of learning directly from interaction with data, not by programming rules, but by providing examples to the machine. Instead of explicitly formulating a rule like, if an email says I won $1 million, then mark it as spam, we actually show the model thousands of emails labeled as legitimate and thousands labeled as spam, and it learns on its own what distinguishes spam from legitimate email. Each such model goes through a process called training. In supervised learning, we provide pairs of examples and labels. For example, a picture of a cat with the label 1 to indicate that the image contains a cat. Similarly, we provide an example that includes a picture of a dog with the label 0. The model makes a prediction based only on the image, compares it to the actual result, calculates the error, and updates itself so that this error gets smaller. This happens thousands of times until the model learns the relationship between the input, the image, and the desired outcome. In other words, the goal of training the model is to reduce the error between the desired outcome, the label, and the actual result, the model's prediction. During training, the model learns to associate features like height, color, and texture with the desired outcome. In classical machine learning, we have to define the features ourselves. What to feed into the model, in what format, and how to balance the data. But this is exactly where deep learning comes in. It's not just one technique, but rather a family of methods based on neural networks. Here, the model receives input, passes it through many layers of transformation, and builds internal representations without us having to manually define the features. In other words, if it's an image, the model will receive all the pixels in the image as input, not features that were defined in advance. And now it's time to say hello to Nita, our teaching assistant.
Hi, my name is Nita. I'll appear here from time to time and share real-life cases with you. In a project I worked on recently, we tried to classify product images based on the visual impression they convey. For example, luxury, brightness, cleanliness. When we use traditional machine learning, we input features like price, category, and user rating. That worked, but as soon as we switched to deep learning methods and fed the images in as they were, we discovered that the real information was in the internal relationships between the pixels. In other words, not necessarily in features we could identify ourselves.
And that's the whole story. With deep learning, we no longer tell the computer what to look for. We let it figure out on its own what's important. By the way, I'm Nero, and I'll be guiding you throughout the course.
Deep learning is a process of learning hierarchical representations. Layer by layer, the information is processed and learned at increasingly deeper levels, down to the level of a single pixel in an image. That's what makes deep learning so powerful, especially with unstructured data. Images, audio, free text. Since 2012, with AlexNet and up to today, deep learning has revolutionized fields like computer vision, speech recognition, translation, sentiment analysis, and content creation. When is it right to break up and learn to recognize? When you have unstructured data, when there's a lot of data, when you want the system to learn representations on its own, or when you need to understand complex patterns that are hard to define manually. But alongside these advantages, it's important to also recognize the various challenges. Deep learning requires high computational resources, longer training times, and most models are considered less transparent. It's hard to understand why a certain decision was made, because the internal representations aren't necessarily easy to interpret.
In other words, it's a kind of black box. It's a complex system of layers, where each one responds to what came before it, and each one reacts to the input from the previous layer.
But if you train it properly and feed it the right data, it can produce insights that we might otherwise miss.
In summary, deep learning is actually the advanced version of machine learning. It's not just an evolution, not just tweaking features, but a significant breakthrough. In the next lessons, we'll learn how to build our own neural network, from the very first layer all the way to the decisions it makes.